Assalamu alaikum warahmatullahi wabarakatuh. Good morning, everybody. Today we have the fourth lesson in chapter 8 in geometry, angles of elevation and depression. By the end of this lesson, you can solve problems involving angles of elevation and angles of depression. First of all, an angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. If you look at this diagram, we have angle number 1. This angle is formed by a horizontal line here, this dashed line, and a line of sight to a point. This point is above the horizontal line, okay? The second angle, which is angle of depression. This angle is an angle formed by a horizontal line also and a line of sight to a point below the line. So we have two important words. The first word above and the second word below. So if the point is above the line, so the angle will be angle of elevation, like angle number 1. And if the point is below the horizontal line, so the angle will be angle of depression. Since horizontal lines are parallel, so angle number 1 is congruent to angle number 2 by the alternate interior angles theorem, like letter Z. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. It means angle number 1 is congruent to angle number 2. Okay. Example 1. Classifying angles of elevation and depression. Classify each angle as an angle of elevation or an angle of depression. Angle number 1. You know that angle number 1 here is formed by two lines. The first line is horizontal and the second line is the line of sight to a point which is below the horizontal line. So angle number 1 is angle of depression. Now angle number 4. We know that angle number 4 is an angle formed by a horizontal line and line of sight to a point above the horizontal line. So angle number 4 is angle of elevation. Also, when I ask you about angle number 2, this angle, yes, it's an angle of elevation because the second line or the line of sight is above to a point above the horizontal line. Here, angle 3 is an angle of depression. Check it out. Please stop the video, okay, and try to solve alone. Now check your answer. Let's see the second example. The settle space needle casts a 67 meter shadow. If the angle of elevation from the tip of the shadow to the top of the space needle is 70 degrees, how tall is the space needle round to the nearest meter? In this question, if you look at this diagram, this is the settle space needle casts this shadow, okay, which is 67 meters. And the angle of elevation, which is angle A, its measure is 70 degree. And I ask you, how tall is the space needle? It means I ask you about this side. So to solve this question, you have an angle, okay, and two sides. One side is given and one side is required. So please name the two sides according to this angle. The given side, 67 meter, is adjacent leg for the angle 70. And the required side is opposite leg. Now, which ratio relate opposite and adjacent? Think and answer. Yes, we have tan. Because tan, the angle, is equal to the opposite leg over the adjacent leg. And in this question, the angle is 70 degrees and the opposite leg is y and the adjacent leg is 67. Now from the previous lesson, how can we find the value of y? If y is in the numerator, so we will multiply both sides by 67. It means to solve this y, it will be 67 multiplied by 1070. Also, you can start with 1070 multiplied by 67, okay? But don't forget to close the bracket, okay? So the answer will be approximately 184 meter, okay? Now, check it out. Look at your book. Suppose the plane is an altitude of 3,500 feet and the angle of elevation from the airport to the plane is 29. So you have 29 is the angle and the altitude or the opposite side is 3,500 feet. What is the horizontal distance between the plane and the airport round to the nearest foot? Stop the video and try to solve alone. Now check your answer. Remember here, when x is in the denominator, so to find the value of x, we will divide 3,500 by 1029 and don't forget to close the bracket. So the answer will be approximately 6,314 feet. I think we will stop today. Please solve the exercise on your book related to example 1 and example 2. Thank you and see you in next session.